In this lesson, we're going to continue talking about trigonometric ratios. This time we are looking specifically at cosine, but I want to remind you of the three ratios and where we are. So in the last lesson, we talked about the sine ratio, and that's abbreviated SIN, of the given angle, theta, and that's always equal to the opposite side of the angle over the hypotenuse. And then today what we're talking about is cosine. So cosine is abbreviated COS, and it's always cosine of some angle theta that you're given, and that's the adjacent side from the angle over the hypotenuse. And finally, what we'll talk about in the next lesson is going to be the tangent ratio. So tangent is abbreviated TAN of theta, and that's equal to the opposite side over the adjacent side to the angle. Okay, using the given triangle to the right, we are going to do the cosine of x and the cosine of y. So starting from angle x, the cosine of that angle is going to be the adjacent side. So the adjacent side of this triangle, if we're looking from angle x, would be side A. The hypotenuse is always going to be directly across from the 90-degree angle. So for the cosine of x, our ratio would be A over C. Adjacent over hypotenuse, so that would be side A over side C. Now if we were looking from the cosine of y, so we're using y as our reference angle, the side that's adjacent to y is the side B, and once again the hypotenuse stays as C because that's directly across from the 90-degree angle. Let's do a few examples. To find the cosine of a given degree measure, all you have to do is type that into a graphing calculator. And before you do that, you always want to make sure that you have your calculator in degree mode. So in Desmos, there's a little tool in the top right corner. You're going to click that, and then down at the bottom, you'll see degrees or radians. So if I leave mine in radians and I try to go to functions and click trig and cosine, and I type in 51, it gives me a measure. And that's fine, but sometimes it will give you a negative number, or it will give you a really abnormally large or abnormally small number. So always just double check that you are in degrees, and notice that that did change this value just a little bit. So the cosine of 51, we're going to round to the nearest tenth. That gives us about 0.6. Okay, number 2. We're going to calculate the cosine of this given angle, which is C. So the cosine of C, so we're looking from this angle. Now remember, cosine is always the adjacent over the hypotenuse. So the adjacent side to angle C has to be 16. That's because 30 would be opposite, and 34 has to be the hypotenuse since it's directly across from the right angle. So the adjacent side, 16, over the hypotenuse, 34. So we need to figure out what that is equal to. So 16 over 34. Make sure we're in degree mode, even though that doesn't really change fractions, but just make sure that you're always there. And that gives us, if we're rounding to the nearest tenth, that would be 0.5. Number 3, calculate the cosine of A. So using A as our angle measure. We're looking for the adjacent side, which would be 30. The hypotenuse is going to be 34. So we are setting up our ratio, which is the adjacent side over the hypotenuse. So our adjacent is 30, hypotenuse is 34. So 30 divided by 34 gives us, if we're rounding to the nearest tenth, that would be 0.9. Number 4, the cosine of angle Z. Right. So 24 is going to be the adjacent side. 30 is going to be the hypotenuse. So if we're going to set up our ratio, that's going to be adjacent over hypotenuse. So the adjacent side is 24 over hypotenuse of 30. And that gives us exactly 0.8. Now let's do a couple of actually trying to find a missing side. All right, now from the given angle measure, which is 73, the adjacent side is x. The hypotenuse, which is directly across from the 90-degree angle, is 6. So we need to set up the cosine of our given angle, which is 73 degrees, is going to be the adjacent, which is x, over the hypotenuse, which is 6. Now we need to solve for x. So in this case, all we have to do to get x by itself is to remove this division by 6. So the inverse of dividing by 6 would be multiplying by 6 on each side. Let me move this over just a little. So we're going to do times 6 on each side. So that allows us to say that 6 over 6, this all equals 1. 6 over 6 is 1, so that can cancel out. That leaves us with 6 times the cosine of 73 degrees is equal to our x. So again, very important to make sure you're in degree mode here. And we're going to calculate 6 times cosine of 73 degrees. So that gives me a side measure for x of 1.8 if we're rounding to the nearest tenth. And number 6 looks very similar. It's not the exact same triangle, but it does favor the last one. Just kind of make sure that you are paying attention to your angle measures and which side you're looking for. So here we have our angle measure is 72. So based on this angle, we have the adjacent side, which is 6, and the hypotenuse, which is x. So we're looking for, since we have adjacent and hypotenuse information, that tells us to use cosine of 72 degrees is equal to adjacent over hypotenuse. Now this one, the process is the same. We just have to do another step, even though we're still just solving for x. So we can't do anything with x until it is not in the denominator anymore. So to do that, we're going to do times x on each side. Now when we do that, x divided by x is 1, so that essentially crosses out. So we're left with x times the cosine of 72 degrees equals 6. Now we're still trying to get x by itself, and since we have x times the cosine of 72, we're going to divide out the cosine of 72 on each side. And I didn't leave myself quite enough room there, but it's going to cross out on this side, and it's going to leave us with x equals 6 over cosine of 72 degrees. So we need to type that into Desmos. I'm going to move this over here, and I'm actually going to write that division on both sides so that we don't get confused. Okay. All right, so we need to calculate 6 divided by the cosine of 72. Again, double check that we're in degree mode. And that gives us approximately 19.4 if we're rounding to the nearest tenth.